This is a video of OCR FP3 January 2007 question 8. It's a de Moivre's theorem question, and part 1 asks us, use de Moivre's theorem to find an expression for tan 4 theta in terms of tan theta. So tan 4 theta we can write as sine 4 theta divided by cos 4 theta. Now, we're going to be expanding these using the de Moivre's theorem, as you know, and I find it quite useful to start with a little Pascal's triangle here. For the powers are reasonably low, so it's going to be a quick and easy way for us to be sure we don't make any mistakes with the numbers in front of the expansions. So sine 4 theta, it's going to expand. Remember, sine is going to start with the second one along. It's going to start positive and then alternate negative and positive. So second one along the expansion is going to be 4c3s. Then it goes negative, and we're going to skip one and get the 4 there, and we're going to 4cs cubed. And cos 4 theta is then going to be the first one along, so 1 times c4 minus 6 c2s2 plus 1s4. So I can write tan 4 theta is equal to 4c3s minus 4cs cubed, all divided by c to the 4 minus 6c squared s squared plus s to the 4. Now, it's always the same process when you want to convert these into tangents. Find the highest power of cos and divide by that. So there's my cos to the 4, it's the highest power there, so I'm going to divide the numerator and denominator by c to the power 4, and divide that by c to the 4, and I'm going to get 4t. Divide that by c to the 4, and I get minus 4t cubed, all divided by, well, c4 divided c4 is 1. Divide that by c to the power 4, and I get 6t squared. And divide this by c to the 4, and I get 1 of t to the 4. And so in terms of tan theta, that's going to be 4 tan theta minus 4 tan cubed theta, all divided by 1 minus 6 tan squared theta plus tan to the 4 theta, which was what they required for the first part of that question. Now, the second part, we'll need to keep that in mind for the second part of the question, required us to then deduce that, I'll bring it up onto the screen, so deduce that cot 4 theta is equal to cot to the 4 theta minus 6 cot squared theta plus 1 over 4 cot cubed theta minus 4 cot theta. Now, it would be tempting to just try and turn this upside down, but notice we want cot, not tan, and that's a negative, and that's a positive, and so on. It's not quite that simple, but not far off. What we're going to do instead is say what we know, which is that cot 4 theta does indeed equal 1 over tan 4 theta, and I'm then going to say, I'm going to turn that expression upside down, but then we're going to modify it slightly to turn it into cots, and it should work out quite nicely. So, I've got my expression. It's not what we want, and it's not in terms of cots, but if we then divide top and bottom in a similar sort of an analogous process to what we did with the cosine earlier, we divide the top and bottom, the numerator and denominator, by t to the power 4, we will get something quite interesting. So divide top and bottom by t to the 4, I got 1 over t to the 4 minus 6 over t squared plus 1 all divided by 4 over t cubed minus 4 over t. So divide the top and bottom by t to the power 4. Now that 1 over t to the power 4 is cot to the 4 theta. So that gets me cot to the 4 theta minus 6 cot squared theta plus cot plus 1, sorry, all divided by 4 cot cubed theta minus 4 cot theta, which is what we actually wanted. Now, then the third part of the question says, hence show that, we'll leave that in place for us for later. Sorry, my paperwork organised here. We've got hence show that one of the roots of the equation x squared minus 6x plus 1 equals 0 is cot squared an eighth pi. Now, x squared minus 6x plus 1, very reminiscent of cot to the 4 theta minus 6 cot squared theta plus 1 if we made a quick substitution. So, from here, if we now say let's write x equals cot squared theta, and then if we say as well cot 4 theta equals 0, then that implies that the numerator of this expression is 0. So that implies that cot to the 4 theta minus 6 cot squared theta plus 1 is also equal to 0. And this, with that expression, that implies that x squared minus 6x plus 1 equals 0. And so then we'll know that values of theta that make cot to the 4 theta equals 0, when substituted into x equals cot squared theta, will also be roots of this equation, x squared minus 6x plus 1 equals 0. So, as ever with these, we're going to then solve the trig equation here. Now, if cot 4 theta equals 0, then that implies that 4 theta is n pi by 2 for n equals 1, 3, and 5. These are the values where cot theta actually equals 0. The values where tan theta obviously heads off to infinity. So 4 theta is n pi by 2, then 1 lot of theta is going to be n pi by 8. Now we only wanted one of these, so that implies that theta equals pi by 8 satisfies the equation. And then we can also say that, tidy this up, so we know that theta equals pi by 8 satisfies cot 4 theta. Then we can say cot squared pi by 8 satisfies x squared minus 6x plus 1 equals 0, which is what we had to show. Now, we've then got one final step in this problem, where they say, hence find the value of cosec squared an eighth theta plus cosec squared 1/8 pi, plus cosec squared 3/8 pi, and justify your answer. And suddenly they've introduced out, seemingly out of nowhere, cosec squared. Now, we know something about cot squared. We know that it satisfies that equation, and but nothing about cosec squared. Now, let's play around with some trig identities here to see whether we can convert our cot squareds into cosec squareds and then do something useful with them. Now, we know that cot squared theta is cos squared theta over sine squared theta, and I also know that 1 over sine squared theta is cosec squared. So if I make a bit of a change here and change that cos squared into 1 minus sine squared theta over sine squared theta, so these are identities, that's going to equal 1 over sine squared theta minus 1, and that's cosec squared. So therefore I can write cosec squared theta is equal to cot squared theta plus 1. And I've got a nice little identity. So if I work out what the value of cot squared pi by 8 and also cot squared 3 pi by 8 is, I'm going to be able to add 1s to those to get the final answer. Now, let's have a quick look. So I've got, and to do that I'm going to need to solve my quadratic up here. So let's do that. So if I've got x squared minus 6x plus 1, that means x is going to equal 6 plus or minus the root 36 minus 4 all over 2, which is going to be 3 plus or minus 2 root 2. Now, so that's a value for x there, which is also, remember, a value for cot squared pi by 8. Now, if we have a quick look at, if we have a quick think back to the earlier diagrams, in here, if we have a quick think, we were saying here that theta equals n pi by 8 are a solution, and we just picked the first one. The second solution would have been 3 pi by 8. So our first solution is pi by 8, our second solution is going to be 3 pi by 8. So I know that cot squared pi by 8 and cot squared 3 pi by 8 are solutions of x squared minus 6x plus 1 equals 0. And a quick check of my diagram, 3 plus 2 root 2 is cot squared pi by 8, and 3 minus 2 root 2 is cot squared 3 pi by 8. Anyway, we need cosec squared pi by 8 plus cosec squared 3 pi by 8. And by our little identity here, we can say that cosec squared pi by 8 plus cosec squared 3 pi by 8 is going to equal cot squared pi by 8 plus cot squared 3 pi by 8 plus 2, because I'll add on plus 1 each time. And so that's going to equal 3 plus 2 root 2 plus 3 minus 2 root 2 plus 2, and that all comes to 8, which is the answer. Thank you very much.